Hi everyone, today we're going to do the last piece of our position, velocity, and acceleration notes. So we kind of have a complete picture of what's going on here. So we're going to talk about two big ideas today. One is going to be determining when you're moving towards or away from the origin, and the other is going to be determining when you're furthest from the origin. So let's start with moving towards or away from the origin. If I'm going to determine this, we need to look at both position and velocity. And so here's what's happening. Let's talk about moving towards the origin. And I'm going to kind of divide this in half. So moving towards, if we think about a number line, I could be moving towards if my original position is positive. So let's say I started somewhere over here. So my position is positive, but my velocity is negative, which would mean I'd be moving to the left and closer to zero. So one way I can be moving towards, if s of t, my position, is greater than zero, and velocity, v of t, is less than zero. Sorry, that's smushed. So I'm starting to the right of the origin, but my velocity is negative, so I'm moving towards the left. The other thing that could happen is if I were starting to the left, so position was less than zero, but my velocity is positive, so I'm moving to the right towards zero. So my position is less than zero and my velocity is greater than zero. Now, on the other hand, we could think about moving away from the origin. And again, we're really going to have two ways that could happen. So one way is that my position is positive. I'm starting to the right. So s of t is greater than zero. And in this case, if my velocity were positive, that would be moving me further from the origin. So s of t is greater than zero and my velocity is greater than zero. The other way could happen is, again, if my position were to the left of the origin, so my original position is less than zero, and my velocity is less than zero. Because then I'm starting to the left and I'm moving further left, so further away. So when we have these types of questions, we're going to have to analyze both position and velocity at a given time to determine that movement. All right, the next question we might be asked is when our object or our particle is furthest from the origin. And so for this, we need to find the max and the minimum positions to find out which value is actually further from the origin. Now, when I'm thinking of maximum and minimum values, I know I need a derivative. So to find this out, we're going to take the derivative of position, which is our velocity function. We're going to set this equal to zero, and we're going to make an options chart. And that's going to include the endpoints of the interval that we're given. Okay, then what we're going to do is we're going to find the largest and the smallest values to see which one is, I'm not going to say not the largest, but to see which one is the farthest from zero. So it could be that our max is further from zero, or it could be that our minimum is, so we would need to analyze that. All right, so let's look at some questions around this. So here we have a particle that's moving along a line with this given position function. And we have our units, s is measured in meters and t is measured in seconds. So at t equals 4, it's asking us, is the particle moving towards or away from the origin? So we said for this, towards or away, we need to look at both position and velocity. So let's go ahead and find our position at time 4. So I'm going to have 4 squared is 16, minus 3 times 4 is 12, plus 1. So 16 minus 12 is 4 plus 1 is 5. So it's greater than 0. So I know I'm to the right of the origin. So if I'm thinking of a number line here, right, here's the origin. My position right now is 5. So now I'm going to look at velocity. So my velocity function, I need that first, is the derivative of position. So it's going to be 2t minus 3. So at time 4, my velocity is 2 times 4 is 8, minus 3 is 5. So since my velocity is also greater than 0, that tells me I'm moving right. So based on that analysis, I know at time t equals 4, the particle, so I'm trying to smush this over here, time t equals 4, the particle is moving away from the origin. So that's how that analysis would look in the context of an actual problem. Okay, now same thing, except they're asking us at time t equals 1. Are we moving towards or away from the origin? So again, first thing I'm going to find is my position at time t equals 1 second. So I'm going to plug it in. 1 squared is 1, minus 3 times 1, so that's a minus 3, plus 1. So I get negative 2 plus 1 is negative 1. So it's less than 0. So I'm left of the origin. Left of the origin. And if I look at my velocity at time 1, well, my velocity was 2t minus 3. So 2 times 1 is 2, minus 3 is a negative 1. Whoops. Is negative 1, which is also less than 0. So I am moving left. So in this case, again, if we think of our number line, here was our origin, my position was negative 1, and I was moving left. Again, our particle is moving away from the origin. So at time t equals 1, the particle is moving away from the origin. And okay. Let's see. Number 3, at t equals 1 is the particle. Okay, so this is a repeat here. So let's see. Let's do, actually, we'll just skip that one because we'll come across this again. So let's move on to 4 then. So over the interval from 0 to 2, when is the particle furthest from the origin? So we said here we need to look at the maximum and minimum position, which we find using the derivative. So we're going to start with our derivative of position. So we know our velocity here is going to be 2t minus 3, and we're going to find out where that's equal to 0. So we get time t equals 3 halves, or 1.5 seconds. So now we're going to go ahead and make an options chart, and we're going to include our endpoints so we can actually find the value of position. So I'm going to have my time, and what I'm trying to find here is my actual position at that time. So my endpoints are 0, time t equals 0, I have 3 halves, and time t equals 2. Now I don't have my calculator with me, so you'll have to bear with me while I do some of this. Alright, so position at time 0. If I plug 0 into my position, I get 1. So 3 halves, so let me put this aside here. S of 3 halves equals 3 halves squared minus 3 times 3 over 2 plus 1. So 9/4 minus 9 halves plus 1. I'm going to give those a common denominator. So 9/4 minus 18/4 plus 4/4 equals, let's see, 9 minus 18 is negative 9 plus 4, negative 5/4, if I did that right. And then if I plug in 2 for my position, S of 2 is equal to, let's see, 2 squared is 4, minus 3 times 2 is 6, and then plus 1. So negative 2 plus 1 is negative 1. Excuse me. Sorry about that. So now I've got my 3 values here. I know this is negative 1.25, and I'm looking for when I'm furthest from the origin. So my position that's furthest from the origin happens to be here at this critical point. So I would say, let's see, let me scoot this up so you can see it. At time t equals 3/2 seconds, the particle is furthest from the origin, because that is the position that's furthest away from 0. All right, so that is the last piece of this position, velocity, acceleration topic. You'll be working on the last chunk of practice, and then we'll be moving on. Thanks for hanging in there and listening to me cough. Sorry about that.